Capsaicinoid extract is extremely unpleasant to get on your skin and in your eyes. However, luckily, capsaicinoids are not particularly toxic. Proper safety equipment such as gloves and goggles are absolutely required. Highly concentrated capsaicinoids on your skin can burn as much as acid, and the burn can last for more than a day. Washing the affected area with water will not do much to relieve the burning. Capsaicinoids are the chemicals in chili peppers that give them their spiciness. The major and most potent capsaicinoid in chili peppers is called capsaicin. Capsaicinoids trigger a burning feeling by stimulating neurons that normally detect heat. The most common use of capsaicinoids is to make food spicy. However, capsaicin does have some other uses, such as its use in pepper spray or as a pain reliever. Extracting and concentrating the capsaicinoids from hot chili peppers can be a fun exercise. The extracted capsaicinoids can have many uses, such as for homemade hot sauce, animal deterrents, or even homemade pepper spray. For the extraction, you only really need two things: a solvent and the peppers you want to extract the capsaicinoids from. In terms of solvents, there's a lot of solvents you can use, such as ethanol, acetone, methanol, etc. However, there's only one thing you have to look out for. You have to make sure that the solvent you choose is anhydrous. This means that the solvent must contain little to no water. Including water in the solvent reduces the solubility of the capsaicin, but moreover, it just makes it more difficult to purify your extract. I carried out the extraction using a Soxhlet extractor, so I only used about 250 milliliters of solvent. I go over in the video and explain exactly what a Soxhlet extractor does and how it works. I bought mine online for about $60, including shipping. If you do not have access to a Soxhlet extractor, you will need about 1 liter of solvent instead. In both cases, the amount of solvent used is in extreme excess and probably less can be used. For the chili peppers, I used 14 grams of dried ghost chili peppers. In theory, you can use any chili pepper that you like, but it's best to get the most potent one. It is extremely important that the peppers that you use are dried. If you buy fresh peppers, simply cut them up and dry them in an oven thoroughly before using them. For the extraction, I used pre-dried ghost chili peppers. First, with my hands, I crushed up the ghost chili peppers to break them up into as many pieces as possible. It is important that the peppers are as dry as possible, otherwise, along with the capsaicinoids, you'll be extracting a lot of water. Excess water will make drying the extract a much lengthier process. I then poured the crushed chili peppers into a clean, food-grade mortar. It is important that this mortar has never come into contact with chemicals if you plan to taste the extracted capsaicin. The peppers were then ground as finely as possible. In the lab, I only had a mortar and pestle, but it is much easier to actually use a coffee grinder or a blender to powderize the peppers. If you choose to use a coffee grinder or a blender, be very careful with the powdered pepper dust that is created. For this extraction, I decided to use a Soxhlet extractor because I thought it would be an interesting demonstration. The Soxhlet extractor is an interesting apparatus which will allow me to speed up the extraction process as well as use less solvent. Without a Soxhlet extractor, another perfectly viable route would be to simply grind up the peppers and let them soak in about a liter of ethanol for a week. After a week, the pepper particulate can be filtered off and the solution can be dried to leave the capsaicinoid extract. The clear advantage of the Soxhlet extractor is that the entire extraction process only took about 3 hours, instead of a week. First, a piece of cotton is placed in the bottom to block the siphon tube. Next, the powdered pepper is poured in on top of the cotton. And finally, another piece of cotton is added in and the pepper powder is packed down. Above the Soxhlet extractor, an Allen condenser is set up. Note, however, in this shot I have not yet attached the water feed and exit tubes. Below I have affixed a 500 ml round bottom flask containing about 250 milliliters of anhydrous ethanol. After the ethanol has been boiling for a while, you can see the vapors climbing up the right arm of the Soxhlet extractor. Eventually the vapors will reach the Allen condenser, and now in liquid form, the ethanol will drip down onto the powdered pepper. You might have noticed that there's only a thin glass wall between the solvent pepper mixture and the vapors traveling up from the round bottom flask. This allows the solvent pepper mixture to be heated up by the vapors as they travel up to the right arm of the Soxhlet extractor. The heating of the solvent increases the efficiency of the extraction. Unfortunately, the angle that I chose to film this on makes this quite difficult to see. So to make the functioning of the soxhlet extractor more clear, I have taken a diagram from Wikipedia to help. It is difficult to see, but the siphon arm to the left of the soxhlet extractor exits at the bottom, goes up a little bit, and then takes a sharp 180-degree turn and then leads back down into the round bottom flask. The pressure created by the solvent in the main chamber of the soxhlet extractor pushes some of the solvent down into the siphon tube. The height of the solvent in the ascending portion of the siphon tube matches the height of the solvent in the main chamber. Eventually, the height of the solvent in the main chamber will reach the height of the 180-degree bend in the siphon tube. As some of the solvent passes the 180-degree bend, the solvent will enter the descending portion of the siphon tube. The solvent in the descending portion will fall due to gravity and behind it create a suction. This will lead to the emptying of almost all of the solvent from the main chamber. This is one complete cycle of the soxhlet extractor. Eventually, the extraction solvent will run clear, which signifies the end of the extraction process. Let the solution cool and then vacuum or gravity filter it. The filtering process is needed even with the soxhlet extractor sometimes because sometimes the small powdered parts of the pepper make it through the cotton and get into the solution. If you did the extraction at home and you did not use a soxhlet extractor, this is going to be your final step. Simply gravity filter your solution into an open top container. Then, leave your solution in a well-ventilated area to allow for the solvent to evaporate. I opted to use a rotary evaporator because it is much quicker. I then washed the round bottom flask twice with 25 milliliter portions of ethanol. I then transferred the solution back to a round bottom flask from the filtration flask. I transferred it back to a round bottom flask because I planned to use the rotary evaporator to pull off all the solvent. I then also washed the filtration flask twice with 25 milliliter portions of ethanol. At this point, I'll just take a second to explain what a rotary evaporator is. It is more commonly referred to as a rotovap, and basically it allows for the quick evaporation of solvent as well as the recovery of the solvent. The rate of solvent evaporation is increased by pulling a vacuum on the solvent. The gaseous solvent is recovered by cooled condenser coils. Because there's very little extract compared to the volume of ethanol, I rotovapped off most of the solvent and then transferred the more concentrated extract to a smaller round bottom flask to continue the evaporation. In the 500 milliliter round bottom, I was left with a lot of ethanol insoluble impurities. I'm actually not sure what this is, and if you have any suggestions, please let me know. I continued rotovapping the extract in a small 10 milliliter round bottom flask. I was left with a red viscous goop. The extract is red due to the presence of an abundant amount of beta-carotene. This is an extremely strong capsaicin extract and should be handled with care. If you completed the extraction using food-grade solvents and materials, then you can test it if you are brave enough. Take a toothpick and scoop up a small microscopic drop with the tip of it. If you touch it on your tongue, I can guarantee you that the potency is enough to make most people extremely uncomfortable. Further extraction of the capsaicin will be extremely intensive and the yield will not be worth your time. From what I've read, most feasible methods will only have a yield of about 1%. A much more feasible method to get pure capsaicin is to synthesize it from the ground up using vanillin and 6-bromohexanoic acid. This is actually a synthesis I'm working on right now, but I'm not sure how far I'll get with it.